Okay, so welcome to part two of the video about hyperbolas. So the first thing that we're going to do is we're going to find the parts of the hyperbola and sketch the graph by when we're given the equation of the hyperbola in a non-standard form. So first of all, we need to find the equation of the hyperbola in standard form, and to do that, we have to complete the square, kind of like what we've done with ellipses. So first of all, we are going to rewrite this where our x's and y's are next to each other. So it's going to be 9x squared, then minus 36x, then we'll say minus y squared, minus 6y. And then we also could take this 18 and move it over to the right side because we will be completing the square. So we need to find new constants there. Then we are going to factor out greatest common factors between x's and y's. So if we're looking at the x's only, the greatest common factor here will be 9. So we'll take 9 and factor it out, and therefore we'll have x squared minus 4x, and then we're gonna find this new value c to complete the square. And if we're looking at the y's, then we need to factor out the negative sign, or -1 if you want, and then we'll end up with y squared plus 6y, and then once again we're going to be looking for the new constant equals -18, and then we should also probably write down two empty spaces because we're going to be completing the square, so whatever we're going to be adding on the left side we'll have to be adding on the right side. And I'm going to move this over so it doesn't interfere with our graph. Okay, so now we need to complete that square. So we know the formula, b divided by 2 squared. So -4 divided by 2 squared, which equals to 4. So we're going to put 4 there in the first parentheses. And then to fill in, we have to add, now please be careful, 9 times 4. Because we don't just add 4, but we add 4 and then 9 that's in the front. So if you distribute that 9 inside, we're actually adding 9 times 4. So that's what we're going to be adding to the right side. And then for the second parenthesis, we'll have 6 divided by 2 squared, which is 9. So we're going to add 9 in the parentheses. But once again, remember that it's on the right side. Imagine that you're taking this -1 and distribute it inside. Therefore, we're going to be adding -1 times 9. Okay, now let's complete the squares. Well, the squares are complete. Now let's condense it. So we'll have 9, and then our first part right here will condense to x minus 2 squared minus 1, and then our second parenthesis will condense to y plus 3 squared equals, and on the right side, once we calculate everything, we should get 9 once. So once we add all of these pieces together, that gives us 9. Now to finish off, remember we should have 1 on the right side. If we look at the original equation, notice that no matter whether we have vertical or horizontal hyperbola, it should equal to 1 on the right. And to do that, we have to, of course, divide everything by this 9. And therefore, equation becomes x minus 2 squared divided by 9 minus y plus 3 squared divided by 9. Oh, sorry, this is not 9, it's going to be 1. Because our 9s, of course, will cancel. And that equals to 1. So this is our equation. Now, once you have an equation, now we can fill in all of the other pieces. Now, here in the question, it says find the parts of the hyperbola and then sketch the graph. I usually will do it all the way around. I will first sketch the graph and then find the parts of the hyperbola, though we could be finding some of the parts as we go. So, first of all, the center. Well, the center is is going to be our h and k, and that's these numbers right here. So our center is going to be 2 and -3. Please remember that we have to change the signs. So it looks like our equation in general is of the form x minus h squared over a squared minus y minus k squared over b squared equals 1. And please remember that with hyperbolas, a is always going to be the denominator of the first fraction, and b is always the denominator of the second fraction. It's not about which number is the biggest. So we can see that in our general equations that we already discussed. So h and k, we found those, and once again we had to switch the signs. So now we can plot the points. So we have 2 and -3. X is 2, y is -3. So this is our center. Now, because our equation has x first, then we know that this is horizontal. So going to be horizontal transverse, or horizontal hyperbola, if you want to call it unofficially, which means that our a is going to be the square root of 1. Therefore, a is equal to 1. And our b is going to be a square root of 9, which means b is equal to 3. So, but we're going to be moving horizontally with our a. So our a equals 1, which means we're going to be moving horizontally 1 to the left, 1 to the right. So these are the vertices. And as we are plotting those on the graph, we can say that vertices will be 1, -3, and 3, -3. So we can see that already from the point. So we fill this in. Then we also we know that b is equal to 3. So we are going to move 3 up and 3 down. And these points don't really have any names, so we don't need to do anything with them, but that allows us to draw this box, this rectangular box, which now will allow us to draw the asymptotes. And from here we can draw our actual hyperbola. And please remember the hyperbola is horizontal, which remember that those blue points are our actual vertices. So the hyperbola will go like this along our asymptotes. So we already know the graph, but we still have a few other things to fill in. So we need to find the foci. So the foci will be inside of our hyperbola. So it's going to be somewhere here. I don't really know exactly where it's going to be, but those are going to be the points. But visualizing them will help me probably to find the coordinates. So we remember that c is the distance, and we remember the formula is a squared plus b squared. So from here we can find c is equal to our a is 1 squared plus 3 squared, and then we of course have to take a square root of all of that. So that will give us a square root of 10. So in this case our foci will be, we can say it's going to be the x coordinate, which is 2 plus or minus square root of 10 comma -3. Eccentricity, well, eccentricity is equal to c over a. So it's going to be square root of 10 divided by 1. So it's just going to be square root of 10. And finally, our equations of asymptotes, well, it's going to be y equals. This is horizontal hyperbola, which means that our slope is plus or minus b over a. So therefore, it's going to be b is 3 over a is 1. So plus or minus 3 over 1 x minus h, which is 2, plus k, which is negative 3. Right? It's negative 3, or you can just write it, of course, as plus or minus 3x minus 2, and then minus 3. You can simplify this just a little bit. So this is the equation of the asymptote. Okay, so that is our graph and the parts of this hyperbola that was given to us by the equation. So once we completed the square, we should be able to find all of those pieces. Yeah, let's look at the other examples. So here we have to write an equation in standard form given the vertices and the foci. So just like with ellipses, it would be helpful for us to sketch the graph so we know which equation to use, and then from there we can find all of the parts. So we have the vertices, which is 2, 3, and 2, negative 3, and on the right already have the coordinate plane set up for us. So we can draw our own intervals and figure out where to plot the points. So 2, 3, so x is 2, 1, 2, and up 3, 1, 2, 3. So that's going to be this point. And then 2, negative 3 will be down here. So we can see that our vertices are on top of each other, which means that this is vertical. Okay, and knowing that this is vertical, we know that our equation will be in the form y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay, so now once we know this, this is very helpful. Let's see what else we can find here. So to find the center, well, that's going to be the midpoint between our vertices. The center is always the midpoint between the vertices or the midpoint between the foci. So the midpoint here is fairly easy to find. It's going to be this right here. So therefore, we know the center is 2, comma 0. So therefore, we can start writing this equation already. So it's going to be y minus the y coordinate of the center, which is 0 squared. Remember that this is your h and k. 2 is your h and 0 is your k. Minus x minus 2 squared. Then we also can easily figure out our a. So a is the distance between the center and the vertex. So this is our a, and it is equal to 3. So it's going to be 3 squared or 9 in the denominator. What we do not know is b. So b, we cannot figure out that easily yet. But we know a few other pieces that will help us to do that. So first of all, I'm going to sketch the graph. It's not necessarily correct because I don't really know how wide this hyperbola is supposed to be, but what it helps me to do is to realize where the foci is going to be. So foci has the coordinates 2, 6. So x is 2 and then y is 6, so it's somewhere here, and 2, negative 6. So that means that the distance from the center to the foci is 6, which means that is our C. So we know that C is equal to 6. So now we're going to use the formula C squared equals A squared plus B squared. And we're going to substitute 6 for C. And we're going to substitute 3 for A. We can write it as 9 already, but I'm going to just write it this way, plus B squared. From here, 36 is equal to 9 plus B squared. And after some simple calculations, we'll get B, let's call it B squared is equal to 25, or you can say B is equal to 5. That's really up to you. Technically, it should be plus or minus 5. Remember, if you take a square root of something, you get both positive and negative answer. But B squared is what we needed. So I forgot to put the square there. So we can rewrite our equation y minus 0 over 9 and then x minus 2 squared over 25 equals to 1. So this is the equation of the hyperbola with those parts. Okay, let's talk about one more example of finding the equation, but here we're given vertices and asymptotes. So the idea is the same. We're gonna graph or plot some of the points to give us an idea of what the hyperbola is going to look like. So we have points 0, 2, and 6, 2. So 0, so first we're gonna put some intervals here. So 0, 2 is this point, and then 6, 2, 1, 2, 3, 4, 5, 6, and then up to is this. So we can see that our vertices lie in a vertical line, horizontal line. So this is going to be horizontal. And therefore, we know that the equation is going to be of the form x minus h squared over a squared minus y minus k squared over b squared equals 1. Now, let's find the pieces if you want. So our center h and k is going to be in the midpoint between these two points. So you can use the midpoint formula if you need to, but in reality, we can of course see that the midpoint in this case is going to be at 3, 0. So sorry, 3, 2, 3, 2, of course. So the x coordinate is going to be this 3, and then the y coordinate is 2. This is our h and k. So therefore, we already know that it's going to be x minus 3 squared minus y minus 2 squared. Then from here, we can also figure out our a. It's the distance from the vertex to the center, and that is 3. So therefore, our a is equal to 3. And therefore, in the denominator, we'll have 3 squared or 9. And of course, once again, b squared is what we do not know. So meanwhile, I will draw this hyperbola. So it's going to look something like this. Now, we're given the asymptotes, and we could graph those asymptotes, but that will be really messy and actually unnecessary, because what we have here is the slope. We know that the slope here is 2/3 or negative 2/3, whichever one you prefer. It's of course easier to deal with the positive slope. So we're going to say that our 2/3, which is our slope, is for horizontal hyperbola, it's going to be b over a. So 2/3 is the same thing as b over a. If we scroll back up, we can see that on our original graphs, that right here, that if we have a horizontal hyperbola, then the slope is b over a. So therefore, we have the ratio 2/3 is equal to b over a. Now, keep in mind, it does not necessarily mean that a is 3 and b is 2. This is the ratio of the two. It's not the actual values. So now, let's substitute the numbers that we know, and the number that we know is a. We know that a is equal to 3. So therefore, we'll have an equation, the proportion, in fact, 2/3 is equal to b over 3. Now, from here, it just happens after we cross multiply and divide. So we get 3b is equal to 6, so b is equal to 2. So the fact that a is equal to 3 and b is equal to 2, in this case, is just a coincidence. It's not always going to be like that. So very common mistake for students to think so. Please don't assume that. You have to set it up as a proportion and actually solve it to figure out what's your a and b are. But we do know that b is equal to 2, then b squared is, of course, equals to 4. And therefore, we can write down the equation. And that is the equation of the hyperbola with those characteristics. Okay, we have one more thing which we need to discuss about the practical applications of hyperbolas, and we need to discuss how to classify all of the four different types of conic sections that we've discussed from just looking at the equation, and then we will be finished. So please watch part 3 of the video.